everyone, welcome to Vedantu JEE English channel. This is your Big B and physics coach. Come on, if you people can hear me and if you people can see me, please say clear, please type in clear, please type in clear. I'm waiting for your reply. Come on. Please say clear. Can you people hear me? Can you people see me? If yes, please say clear. Okay, no aspirants. Okay, man, he said clear. Good. Let us continue. See, we have completed majority of the waves, but we haven't completed longitudinal waves, right? And when I talk about longitudinal waves, majority of the chunk is going to be having questions from sound waves. Sound waves are the ones which are going to have a lot of questions. So first, we will talk about how the longitudinal waves can be represented. We can represent in the form of displacement wave, in the form of pressure wave. And let me tell you one thing, our brain is going to be processing the pressure variations that are going to be created at the eardrum. At the eardrum, there will be pressure variations created. So based on those pressure variations, the brain is going to process the sound. So whenever it is us who is going to be processing the sound, we will be processing the sound in the form of pressure waves. So pressure waves are the ones which we have to deal with when we are going to be talking about how we feel. But while solving questions, we can represent it in the displacement wave form and deal with it. So all those things we are going to discuss today. Whatever I have given a glimpse of what we are going to do. In detail, clearly we are going to discuss about all these things. Good evening, good evening, good evening. Okay, as usual, MVSAT. If you have any siblings or cousins, younger ones, as it's a free test, make sure you make them write it. They get a lot of benefits, and if they want to enroll into Vedantu offline centers, it will be of a very it will be a very big thing for them. Reason being, you can get a lot of scholarships. So that's the reason why. Okay, now waves part 2. As I said, we discussed about transverse waves in the previous class in detail. Today we will be talking about longitudinal waves, and we will be talking about representation of those longitudinal waves. So when I'm going to be talking about longitudinal waves, how the particles of the medium are going to be moving. The particles of the medium are going to be moving along the propagation of the wave, right? Along the propagation of the wave. They are going to be moving along the propagation of the wave. So basically, if I am going to talk about this particular layer, this layer will do to and fro oscillations. That means this layer is going to be moving like this. As a result, you get compressions and you get rarefactions. As a result, you will get compressions and rarefactions. So what will happen? Some regions are going to be crowded. Some regions are going to be crowded, and some regions are going to be having a lot of gap between them. So where there is huge amount of gap, that we are going to call as a rarefaction, and wherever the particles are crowded a lot, we call it as compression. So why I am representing this is that there are locations where there is lot of crowding, and you can see less crowding. As a result, there will be pressure variations. So when a longitudinal wave is going to be moving, you will come across pressure variations. So when I speak, yes, the particles are going to be getting crowded at one location, are less crowded at a location. As a result, pressure variation will be there, and those pressure variations will be felt by our eardrums, and the brain will process it and you hear the sound. Okay. Now, in order to understand these longitudinal waves, right? In order to understand these longitudinal waves, we have to represent them mathematically. If we can't represent them mathematically, we can't study them, right? So, if I am going to talk about displacement way of representation, what is displacement way of representation? See, we have a layer, right? And this layer is going to be performing oscillations. And how it is going to? It is going to perform oscillations like this. So the displacement from the mean position, I will represent it with y. And one more thing, this is a layer which is at some x distance. These are the layer of particles which are at x distance, and that layer is going to be oscillating like this. So whatever I have explained to you for transverse wave, y is equal to a sine omega t minus kx, or y is equal to a sine kx minus omega t. See, these are the waves which are going to be traveling in positive x direction. So the same wave equations only, man. Only thing is that in transverse wave, the displacement was in the vertical direction. In longitudinal waves, the displacement will be along, but it will be the same amount of displacement. That's what you have to keep in mind. So basically, if I am going to talk about a sine omega t plus kx, and if I am going to be talking about y is equal to a sine minus omega t minus kx, yes, these are the waves traveling in negative x direction. But still, the wave equations will remain as it is. Only difference is that in transverse waves, the particles were oscillating perpendicular, and in longitudinal waves, the particles will be oscillating along. Okay, now, as I said to you, when a wave is going to be traveling, when a longitudinal wave is going to be traveling, there will be pressure variations. So normally when you have particles, let's say you have the particles which are not moving at all, if you have particles which are not moving at all, then the average pressure they are going to be experiencing is going to be P naught, which is going to be the atmospheric pressure. Atmospheric pressure. But now what will happen when a disturbance is going to be traveling through the medium? Then there will be compressions as well as rarefactions. So basically the volume is going to change. So as disturbance travels through the medium, as the disturbance is going to be traveling through the medium, there will be volume changes. There will be change in the volumes. There will be change in the volume, resulting in what? Resulting in change in pressure. Resulting in change in pressure. So I want to talk about how those pressure variations are going to be. So initially I thought of deriving it, but I feel that you don't need that level of derivations and all that stuff, because they are not focused much in JEE mains, right? So when the JEE advance is going to come, I'll derive it, but although I will give you hints. See, using bulk modulus, we know that the bulk modulus is going to be dP by, for a gas, you can write it as dP by minus dV by V. This is going to be the bulk modulus. So using this, dp we can, what is dp? dp is changes in pressure. dp is changes in pressure. So when you are going to calculate the changes in pressure, if the displacement form, if the longitudinal wave you are talking about is represented as, let's say, y is equal to a sine omega t minus kx in the displacement form, then for this wave, the pressure variations will come out to be bak cos omega t minus kx, or excuse me, the pressure variations I'll represent with delta P is going to be BAK sine pi by 2 plus omega T minus Kx. What is the pressure amplitude here? See, this is displacement wave and this is called as displacement amplitude. This is called as displacement amplitude. Now, we can represent the very same longitudinal wave in terms of the pressure variations it is going to create. Now, what this can be called as, logically if you think, can we call this as pressure amplitude? Can we call this as pressure amplitude? Yes. And that pressure amplitude, I'll write it as PA. Pressure amplitude, I'll just represent it with some PA. Either you can represent like that, or you can represent the longitudinal waves in this form. Okay, fine. Sir, how frequently are we going to use these pressure waves? Very rare. Very, very rare. If you know this much, it's more than enough. Next, I'll give you a few more additional points which are going to be helpful for you for your JEE mains, as well as to some extent in your JEE advance also. Now look, what did we get? So if I am going to choose a layer of particles, normally the pressure over here should be what? P naught. But when the longitudinal wave is made to pass, when the longitudinal wave is made to pass, longitudinal wave is made to pass, obviously at that location pressures are going to change. So look at this, the pressure change can be plus BAK, right? When this whole thing is going to be plus 1, can be minus BAK also when this whole thing is going to give you minus 1. So the pressure change, if we talk about the pressure change, it can be BAK. That means the pressure at that location minus the mean pressure, or you can say the atmospheric pressure. So at one point of time, the pressure can become P naught plus BAK. Now sometimes the pressure is going to be, let's say the pressure change is going to be minus BAK. So pressure at that location minus the atmospheric pressure is minus BAK. So in that situation, what will be the pressure? P naught minus BAK. That means if there is a person, whoever is going to be standing at this location, if it is me, if there is no disturbance, you treat me as those layer of particles. Once again, you treat me as those layer of particles at my location. If no disturbance is going to be passing through me, the pressure I will experience is simply atmospheric pressure, which is P naught. Now when the disturbance is going to pass through me, the maximum pressure I experience is P naught plus BAK. P naught plus BAK. And the least pressure I am going to be experiencing is P naught minus BAK, right? So what is the maximum pressure difference I am going to feel? Is it 2 BAK? This is one important point. The max pressure difference The maximum pressure difference felt at a point is going to be 2 times BAK, because I experience P naught plus BAK also, I experience P naught minus BAK also. So what is the pressure difference maximum I am able to feel? 2 times BAK. Second observation. This is one important thing. Now one more observation. If you are going to represent the longitudinal wave in the form of displacement wave, but if you are representing it in the form of pressure wave, now you tell me, what is the phase difference between displacement wave and pressure wave? So the phase difference between them, is pi by 2. The phase difference between them is going to be pi by 2. If any two quantities will have a phase difference of pi by 2, if one is going to be reaching maximum, other is going to be reaching minimum. For example, this is sine, this will be cos. When sine is maximum in magnitude, cos will be 0 in its magnitude. When cos is maximum in its magnitude, sine will be 0 in its magnitude. So whenever you have a phase difference of pi by 2 between any two quantities, not only over here, if the phase difference is pi by 2, if one quantity is maximum in magnitude, the other quantity is going to be minimum in magnitude. Right? This is one more thing. Next, sir, you gave intensity of transverse wave, right? Or intensity of wave you have given. You have given intensity of wave. But although I haven't mentioned it to be transverse, I just mentioned intensity of wave, and then I was talking about power supplied to the particle. So the particles are going to be common in transverse as well as longitudinal waves. In longitudinal waves also we will have particles, right? In longitudinal waves also we will have particles. So the force we apply and the velocity F bar dot V bar is going to give you how much power is going to be given to that, and the power that is going to be flowing per unit area is going to be intensity. So whatever the intensity formula I have given to you, which is half rho a square omega square into V, is still valid here also. But here there is no pressure amplitude involved in it, right? So you can do some modifications. And you can get. But for that, you need to know the speed of longitudinal wave. So speed of longitudinal wave in fluids is given by root B by rho. And speed of longitudinal wave in solids is given by root y by rho, that is Young's modulus by rho. Here B is bulk modulus. You can use this one and you can convert this into pressure amplitude form. Which is going to be half the pressure amplitude square into V divided by B. This formula is helpful for some previous year's JEE mains questions. Like there are 1 or 2 questions which demand this. The pressure amplitude, every one of you know that, BAK. Pressure amplitude is BAK. So are you going to mug this one up? My suggestion to you is that don't do that. You anyway know this. Use the speed of the longitudinal wave in fluids to be root B by rho, right? So using that, you try to get rid of this rho. You try to get everything in terms of pressure amplitude, that is BAK, V and B, then it's fine. You can do it in examination also, it's not a big deal. Okay. Now the most important one, the sound waves. Sound is a longitudinal wave. And if I'm going to talk about speed of sound in air, what formula I have to use? So when I say speed of sound in air, what is air? Air is a fluid, right? So speed of sound in air is going to be what? Root B by rho. Root B by rho, where B is bulk modulus. Okay, fine. Now, what Newton has said. Man, when I speak something, Newton is like this. Newton is like this, saying like this, that when we speak, it's traveling fast. If it is traveling fast, I can't see I can't see any visible changes in the temperature of the surroundings. So when this wave is going, or when the sound wave is traveling, it is not heating up the medium. It is not heating up the medium. If it is not heating up the medium, that means the sound is propagating in isothermal process. So Newton thought that, what did Newton think? He said that sound travels in isothermal way. Sound travels in isothermal way. For isothermal process, the bulk modulus is P, pressure. This you will get to know in mechanical, or you can say properties of matter. When bulk modulus is going to be done to you, bulk modulus for gases is going to be calculated, bulk modulus for isothermal process will be calculated, bulk modulus for adiabatic process will be calculated. So now I am skipping it, but those who want to do it, every one of you know that the bulk modulus is change in pressure by fractional change in volume. So you can take PV is equal to constant and then differentiate to get this, you are going to get this one. Now, then the speed of sound in air, we know that it's root B by rho. So the B they have put as P and the rho value. P is going to be what? The standard, that STP thing, right? Standard temperature and pressure. At standard temperature and pressure, whatever the pressure will be there, you put that. And the density of air also, roughly, you know the value. So when you put all those things, this came out to be around 280 meters per second, man, which didn't match with experimental results. It didn't match with experimental results. People expected something, right? Speed of sound, experimentally they calculated it was around 330 meters per second. And when Newton is taking that it is traveling in isothermal way, then the speed is not turning out to be 330, it is coming out to be around 280, which is definitely wrong. Right? So then there is this fellow called Laplace. So what he did, he gave the correction. No, as the sound is going to be traveling very fast, it is not getting time to exchange heat. So we have to take that the sound is traveling in adiabatic process. Adiabatic process, because it travels so fast, it's not getting any time to exchange heat with the surroundings. So PV power gamma, you have to take it to be constant. So the bulk modulus for adiabatic process, when you calculate, it will come out to be gamma P. So then speed of sound in air is root B by rho. So when I am going to put that gamma P by rho, and when I am going to be substituting the gamma for air and P as well as rho, then this came out to be roughly 330 meters per second, matched with the experimental result. That means who is correct? Laplace is correct. Who is correct? Laplace is correct. Okay. As Laplace is correct, let us try to See different forms of this speed of sound in air. Gamma, pressure, right? Pressure can be written as what? nRT divided by V divided by rho. What is rho? Okay, let us talk about that. Rho is density, right? Density is going to be what? Mass by volume. So then this V can be written as gamma n R T by V, density mass by V. V and V are going to get cancelled out. So the speed of sound in air is going to be gamma RT by the total mass divided by the number of moles. Total mass divided by number of moles will be what? Molar mass, right? Actually, this form is very famous than this form. Gamma P by rho. Why? As pressure increases, there can be changes in the density. So this is not a direct relation. But here, if temperature increases, for sure the speed of sound is going to change. Because gamma of air is constant, R is a gas constant, M0 is molar mass which is a constant. So we can simply say that speed of sound in air is directly proportional to root T. Speed of sound in air can be directly written as root T. Okay. Now look. Okay, Kavya is asking something. Meanwhile, you people just write it. सर हमको अच्छा फैकल्टी नहीं है, वी आर प्रिपेयरिंग बाय आवर ओन, बहुत डर लग रहा है सर, थोड़ा टिप्स दे दीजिएगा. सी फर्स्ट, don't try to learn 100% of the syllabus. If you are afraid, the very first thing you will try to do is you will try to learn 100% of the syllabus, which is a bad thing. So be smart, target that easy section first. First you complete those chapters. Some 60 to 70% of chapters are easy to manage in physics. If not 60 to 70, might be even if you are going to be an average student also or below average student also, 40% of the chapters are easy to understand. 40% is going to be 40 marks in physics, right? So from there on, once you complete all those easy chapters, then you start working towards the moderate chapters. In that way, you are going to be easily clearing stuff. Like you will be able to easily get through 180 marks. Getting through 180 marks is not going to be a problem, but this year if you are going to get 180 marks, you will get a decent rank. Keep that in mind. Okay. Now, as we have pressure in the numerator, if you are going to say that as pressure increases, speed of sound in air will increase means, no, you can't say, because as pressure is going to be changing, the density can change. So both of them are dependent on each other. So on what parameter the speed of sound is going to depend? First, as temperature increases, speed of sound for sure will increase. Speed of sound for sure it is going to increase. Second, as pressure is increased but temperature is kept constant, then the speed of sound will not change. Then the speed of sound will be constant. It won't change. So that is what I was trying to tell you people. That is what I was trying to tell you people. So just because they have given pressure increases, don't say that pressure in the numerator, as pressure is in the numerator, so for sure the speed also should increase. It's not like that. As I said, as pressure increases, density might also increase in the same way. As a result, P by rho might come out to be constant. That's why better way to analyze the speed of sound, whether it is changing or not, is using this. Root gamma T by M0. Okay. Now, the third one, humidity. So if there is more humidity, if humidity is going to be increasing, that means you have more and more water molecules in air. If you have more and more water molecules in air, that's an indication that some of the nitrogen molecules are replaced with H2O molecules. N2 is heavier than H2O. So if N2 is replaced with H2O, as a result in a given volume, the mass got reduced because N2 molecules have been replaced with H2O. So if the mass is going to get reduced for a given volume, density decreases. Right? So as humidity increases, density decreases, so the speed of sound increases. So if you maintain same pressure, but if the humidity is increasing and pressure is maintained the same, in that situation, as the density is going to be decreasing, speed of sound in air will increase. Speed of sound in air will increase. So these are the parameters you people should have in your mind. These are the parameters you people should have in your mind. Okay. Now, how loud is going to be a sound? How loud is going to be a sound? So, we have to take something as our reference. So, a sound whose intensity, a sound whose intensity is 10 to the power minus 12 watt per meter square is taken to have zero loudness. That's the reference they have taken. And the intensity of sound is going to be measured in dB, decibels. If you want, look at this formula. What this formula says is that the intensity, or not intensity, loudness is going to be 10 times log base 10 I by I naught, where I is the intensity of the sound, I naught is 10 to the power minus 12. So if the intensity of the sound is going to be 10 to the power minus 12, then 10 to the power minus 12 by 10 to the power minus 12 will give you log 1. What is log 1? 0. So when they were defining loudness, loudness is a relative term. For some people, one particular sound might be very loud. For other people, it might be normal. That's why they have to take a reference. So scientists have taken a reference saying that if any wave is going to have an intensity of 10 to the power minus 12, that intensity one is taken to have zero loudness. And the unit for that loudness is going to be what? dB. And what is intensity, man? Intensity is going to be the power reaching per unit area. So basically, mostly what I have seen in JEE is that they take a point source. A point source which is going to have some power P. Like, what does that power P indicates? It is going to be giving out energy in all the directions. The rate at which it is going to be sending out energy is going to be defined by the power. Now, if there is someone who is going to be at a distance r, so we have a person standing here. So what is the intensity of that particular thing he is going to reach or he is going to get is going to be the power that is going to fall on this entire area is how much P. So the power that is reaching per unit area is going to be called as the intensity. So if you are closer to the source, R will be less. If R is going to be less, I will be more. That's why when there are speakers, if you are closer to the speaker, then the loudness will be more. If you are away from the speakers, loudness will be less. Why? If you are away, if R increases, intensity decreases. If intensity decreases, loudness decreases. That's what you sense, your ears are going to sense. I didn't get you, Saundarya. Please apply dye and come. What dye? Now, take a question on this. Take a question on this. A small speaker delivers 2 watt of audio output. At what distance from the speaker will one detect 120 dB intensity sound? Okay, they are asking at what distance. It is bit calculative. It is bit calculative. Okay. Now look, first of all, they have given the loudness. It's 10 log 10 I by I naught. Beta is how much? 120. It's 10 log 10 I by I naught. So this gets cancelled out. So I by I naught is going to be how much? Is going to be 10 to the power 12. We already know the I naught value. Na? What is the I naught value? I naught value is 10 to the power minus 12. As a result, the I is going to come out to be how much? 1. I is going to come out to be how much? 1. Now look, they are talking about at what distance we have to stay such that intensity will be 1. Simple man, you draw, we know the power, so the intensity is going to be P by 4 pi R square. So the distance at which you have to stand is going to be R. So R square is going to be P by 4 pi. So R is going to be what? This. Because I is 1. I is 1. P is 2. So you'll get 1 by 2 pi. So it is going to be 1 by root 2 pi. That's what you have to calculate and you have to mark. That's why you have the answers in terms of centimeters, because this is going to be less than 1. So in meters it is less than 1. That's why they have converted it into centimeters. One more question. 2019 online. 2019 online. A small speaker delivers 2 watt of audio output. At what distance from the speaker will one detect 120 dB intensity sound? 120 dB intensity sound. Okay. It's the same question, right? The one which is asked, I think this was asked in 2022 or 2023. This question has been asked. And do we have a same question in 2019 also? So what will be the answer? Isn't it going to be the same thing? 1 by root 2 pi. 1 by root 2 pi. Yes. So now, let us go for standing waves in organ pipes. Man, I will not be talking about how standing waves are going to get created. Because when you have a fixed end, when you send a wave, when you send a disturbance, it gets reflected. So you have a wave which is being continuously sent, you have a wave which is getting continuously reflected, you have two waves in the opposite direction. And I clearly proved in the previous class also that a wave can reflect from free end also. So now, when we are going to talk about organ pipes, we have two types of organ pipes, man. One is going to be closed organ pipe. One is going to be closed organ pipe. The other is going to be open organ pipe. The other is going to be open organ pipe. Right? So when I am going to talk about closed organ pipe and open organ pipe. What is a closed organ pipe? Look, if one side is going to be closed and if one side is going to be open, we call it as closed organ pipe. Let us take the length of it to be capital L. If the pipe what we have taken is going to be open from both the sides, then we are going to call it as open organ pipe. Closed means it's not closed from both the ends, keep that in mind. Now, as it is a fixed end, so this is the place where we should have what? Displacement node. I said to you, right? Pressure waves and displacement waves have a phase difference of pi by 2. So, if the displacement is going to form a node, then here there will be pressure antinode. So, what does a displacement node mean? The particle over there will not move at all. Then that's the particle which will experience maximum pressure changes in terms of pressure waves. Why? You imagined you are against a wall. You are there in a room packed with people. You are to the wall. So when the people are going to be pushing you, even the wall is going to be pushing you. Then you will be under tremendous pressure. When the people in front of you move forward, all of a sudden you got a lot of breathing space. There is space in front of you because the people in front of you have moved forward a bit. As a result, you have a lot of breathing space. So you are the one who is compressed a lot. You are the one who is going to relax a lot. So you are going through maximum emotions. You are going through maximum pressure changes. So whenever things are maximum, we call it as what? Antinode. So wherever displacement node is going to get created, there pressure antinode is going to get created. And this is the first and last time I am going to talk in terms of pressure. That's it. So I am going to deal the whole class in terms of displacement nodes and antinodes. Whenever in the examination, if they ask by any chance pressure nodes and pressure antinodes, wherever displacement node gets formed, there pressure antinode gets formed because the phase difference between them is pi by 2. That's how you memorize. Okay. Now, it's a free end. As it is a free end, for sure here it should be displacement antinode because that particle over there is free. So it can have big amplitude of oscillations. Now, it is mandated that there should be a displacement node here. It is mandated that there should be a displacement antinode over there. I think they can be two successive node and antinodes. No? If they are going to be two successive node and antinodes, how we have to draw? We have to draw like this. We should not draw the complete loop. If we are going to be drawing the complete loop, from node, we are going to the other node. No, we are somewhere in between only. Those who are not able to understand, let me show you yesterday's class. Yesterday's class I have drawn horizontal, but now I am drawing those loops vertical. So you have node, node, node. This is the place where antinode will be there. This is the place where antinode will be there. Now, what is the distance between successive node and antinodes? Lambda by 4. So we can write this as lambda by 4. Come on, man. You have to. If you have any doubts, you keep texting in the chat box, I'll reply. You can see it or you can feel it. You can see it through my eyes. My eyes are red. Actually, I'm a bit sick. And I have a running nose also. So you can hear it sometimes. Still, I'm trying to do this. Reason, before the Diwali break, if I complete this chapter, you will be getting at least 4 or 5 days to solve questions. So that's the commitment I am giving from my side, right? So you people also should take it seriously and do the question sincerely. Just listening to the things will not give you anything. Okay, fine. Now look. So this lambda by 4 is nothing but L or not? Yes. So the lambda by 4 is going to be equal to what? L. So the lambda is going to be what? 4L. And the frequency we are talking about is V by lambda. So the frequency is going to be what? V by 4L. This is the very first frequency that is possible. That's why this is also called as fundamental frequency. Same wording, man. And what is the integer we have multiplied to the fundamental frequency? It is 1 into V by 4L, right? So this is also called as first harmonic. This is also called as first harmonic. Okay, let us come to the open organ pipe. When we come to the open organ pipe, there should be an antinode. When I say antinode, I am not explaining again, it is displacement antinode. Because the particle which is at the free end is going to have big amplitude of oscillations because it's free. So the fundamental thing that can get formed over here is going to be these being two successive antinodes. So between two successive antinodes, will there be a node? Yes. So how it is going to get formed? It is going to be like this. It is going to be like this. Man, what is the distance between two successive antinodes? I can simply write it to be lambda by 2, sir. So here I can simply write lambda by 2 to be equal to L. So the lambda is going to be 2L. So the frequency possible is going to be V by lambda, which is going to be V by 2L. So this is the frequency which I am going to call as fundamental frequency. And for your kind information, this is mentioned a lot in the notification. Fundamental frequencies of organ pipes. In JEE mains notification, they have repeatedly mentioned this. Fundamental frequencies of organ pipes are there in the syllabus. And as usual, if you see majority of questions in JEE mains, they were on fundamental frequencies only. Look, you take same length of organ pipe. One is a closed one is an open one. The fundamental frequency of closed organ pipe is V by 4L. And the fundamental frequency for the open organ pipe is V by 2L. And the integer we are multiplying is 1. So we call it as first harmonic. It is also called as first harmonic. Whatever the integer will be multiplied to the fundamental frequency, we call it as that harmonic. Keep that in mind. Next, let us talk about the next possibilities. We have a closed organ pipe and we have a open organ pipe. I know that this end we have a node and this end pakka it should be an antinode. So this being two successive node and antinodes we have already dealt. So what is the next possible thing? The next possible thing is going to be having one more node in between. As a result, how it is going to look like? It's going to be like this. Then you tell me, this is going to be some lambda dash by 2. Why did I use lambda dash? Because for the same size of the pipe, if we are accommodating more loops, then obviously size of the loops has to decrease. So if the size of the loop is going to decrease, wavelength is going to decrease. So now look, lambda dash by 2 plus lambda dash by 4 is your L. So 3 lambda dash by 4 is your L. So the lambda dash is going to be 4L by 3. Okay, we got. So the new frequency is going to be V divided by lambda. So V divided by 4L by 3, which is what? 3 times V by 4L. So the next possible frequency for which standing wave is going to get formed is 3 times V by 4L. First V by 4L, now 3V by 4L. That means 2V by 4L is missing. The integer we have multiplied here is third harmonic. Is third harmonic. And look, this is also going to be called as first overtone, because this is the first extra tone you are going to get. This is the first extra tone you are going to get. Okay, fine. Let us go for the open organ pipe. When I talk about the open organ pipe, for sure there should be an antinode here. For sure there should be an antinode here. So there should be antinodes, right? And now, if I am going to talk about these two are not two successive antinodes. These two are not two successive antinodes. Then what is the possibility? There is one more antinode in between. There is one more antinode in between. There is one more antinode in between. Now this new wavelength, whatever is there, let us write it. This is lambda dash by 4. This is lambda dash by 2. This is lambda dash by 4. As a result, the total length is 2 lambda dash by 2. And the length of it, we have already defined it to be L. So from here, the lambda dash is going to be what? 2L by 2. So the new frequency for which the standing wave possible is 2 times V by 2L. Is 2 times V by 2L. So what is this? 2 is multiplied. So I can say this to be second harmonic. We can say it to be second harmonic, right? And this is also our first extra tone. So we will call it as first overtone. First overtone. Okay. Now, one last comparison, man. One last comparison. One last. After that, you people can see the trend, right? Closed organ pipe. We are talking about the same length of the one, L. What are the conditions that have to be met? What are the conditions that have to be met? The conditions that have to be met for standing wave formation is going to be, there should be a node here, there should be a antinode here, right? So we have already discussed two successive node and antinodes, and then one more node being in between them. And now let us talk about two more nodes being in between them. So if there are two more nodes, one over here, then you will have loops like this. So now this, I'll take it to be lambda double dash by 2, this lambda double dash by 2, and this lambda double dash by 4, which will turn out to be how much? 5 lambda double dash by 4 is equal to L. So from here, lambda double dash is 4L by 5. So the new frequency for which standing wave is possible is this, which is going to be what? 5V by 4L. Now you tell me, what is the integer that is multiplied? Yes, 5. So this is what? Fifth harmonic. And this is also your second extra tone. Again, what happened, man? The frequency for which standing waves are possible are V by 4L, next possible is 3V by 4L, and the next possible is 5V by 4L. Then what happened to 2V by 4L? What happened to 4V by 4L? So all those even numbers are missing. So for those even frequencies, standing waves are not possible. That's why they are missing. Okay. We should have for sure an antinode here and for sure an antinode here. Already we discussed about one node in between. Then we can also have two more nodes in between, right? 1 and 2. This we already discussed, I think. Yes. This we already discussed. Antinode, one antinode we have already discussed. Now we need to have two antinodes, right? We need to have two antinodes. So let me just mark one antinode here and one antinode here. So then what should be the thing you are going to get? You will get like this. Those green ones I am talking about are antinodes. Now look, we have 1/4 of the loop, which is going to be lambda double dash by 4. We have two complete loops, which are going to be what? Lambda double dash by 2 and lambda double dash by 2, and this is going to be lambda double dash by 4. So if you are going to add all of them, then you get 3 lambda double dash by 2 is going to be L, and the lambda double dash is 2L by 3. So the new frequency for which standing waves are possible is this, which is going to be 3 times V by 2L. So what's happening? This is third harmonic. Whatever the integer is going to be multiplied, I already said to you, right? Whatever the integer is going to be multiplied, that's that harmonic. And is this the second extra thing you are going to get? That's why this is called as a second overtone. Now, if you look at closed organ pipe, even harmonics are missing. And if you look at open organ pipe, we have even harmonics. We have odd harmonics also. So in a closed organ pipe, in a closed organ pipe, even harmonics are missing. So if you are going to talk about the ratio of frequencies for which standing waves are possible. So F1 is to F2 is to F3 is to, and so on. If you are going to talk about, it is 1 is to 3 is to 5 is to 7 is to, and so on. In an open organ pipe, if we are going to compare, then F1 is to F2 is to F3. So if you look at the ratios of these things, it is 1 is to 2 is to 3 is to 4 is to, and so on. So all those harmonics are present. So standing waves are not possible again. Once again, it is a clear proof that standing waves are not possible for all the frequencies. For closed organ pipe, it is possible at V by 4L. Next, it is possible at 3V by 4L. What about the frequencies in between? Not possible. Why? Some conditions have to be met for closed organ pipe. What are those conditions? There should definitely be a node at the closed end and antinode at the open end. Now let us look at this open organ pipe. Are all frequencies possible for forming the standing waves? Means no. What are those frequencies for which it is possible? V by 2L. Next it is for 2V by 2L. What about the frequencies between V by 2L and 2V by 2L? No, standing waves are not possible for those frequencies. That's it. As simple as that. Okay. Okay. Enough. End correction. This is something which has been ignored when I was doing these calculations. Although purposefully I have drawn the antinodes out of the pipes, but still I have taken this whole length as length of the pipe. So what is end correction? What was observed is that antinodes are not formed exactly. Antinodes are not formed exactly at the open end. Antinodes are not formed exactly at the open ends. They were slightly outside. They formed slightly outside. It's obvious, man. See, when I'm going to talk about a particle which is exactly at the edges, is it completely free? Means no. Downside it has pipe. So when I'm going to be talking about a exact, like a perfect free particle, so it should feel that throughout its oscillations, it is not affected by anything. That's what we call as a free one. So the free one is going to be just outside. That's something which these people have not taken into consideration. So you should take the correction for it. So if it is a closed organ pipe, we have only one antinode, right? We have only one antinode and we have a node. Antinode got formed, let's say, at E distance from the edge. At E distance from the edge. Then if I am going to talk about the fundamental frequency, see, this is the length of the pipe, which is capital L. And what is the distance between node and antinode? Successive node and antinodes. Successive node and antinodes, the distance is going to be how much? Lambda by 4. So the lambda by 4 should actually be equal to what? L plus E, man. Now you tell me what will be the lambda. The lambda is going to be 4 times L plus E. That means what will be the actual frequency? V by lambda. So what is that lambda? 4 into 1 L plus E. But, excuse me. I'll just come. 2 minutes. Just wash my face and drink some hot water and I'll come. 2 minutes. Okay, let's see. Okay, so the end correction is going to come only in the case of antinodes just outside are going to get formed. Now let us talk about the open organ pipe. What is the problem with the open organ pipe? The open organ pipe has two antinodes. Sir, then should we take two end corrections? Yes, exactly. If you take an antinode here and if you take an antinode here, for sure for both these antinodes you have to take the end correction into account. Now if I am going to be talking about the very basic thingy, that is the fundamental frequency. So the fundamental frequency, look, these being two successive antinodes. And what is the distance between two successive antinodes? It is going to be lambda by 2. Now you tell me, what do you get lambda by 2 as? You get lambda by 2 as L plus 2 times the end correction. So the lambda is going to be what? Lambda is going to be 2 times L plus 2E. So the frequency is going to be V by lambda. In this case, it is going to be V by 2 times L plus 2E. So in the case of open organ pipe, you have to take the end correction on both the sides, because wherever antinodes are there, you have to take. But for closed organ pipe, you have antinode only on one side. So if you take end correction on that side, it's more than enough. Very good. Spread weight. Now look, sir, what if they are not going to give the end correction? If they don't mention anything, if they simply talk about closed organ pipe, open organ pipe, then don't take end correction into consideration, right? So there is one formula also for end correction. It is 0.6 times the radius of the tube, or it is 0.3 times the diameter of the tube. Now there will be a question to you, sir, when to use end correction? How we will get to know in which question we have to use end correction? How do we get to know in which question we have to use end correction? Look, if radius or diameter are mentioned, if radius or diameter of the tube are mentioned, then yes, they are expecting you to use end correction. If it's an experiment, what does experiment mean? That means we are doing it for real, and in reality, do we have end correction? Yes. Then should we take end correction? Yes. Precisely. What is that experiment we are going to talk about? We are going to come across something called as resonance tube method or resonance column method. So when they talk about resonance column method, then for sure you should keep in mind that there is end correction. Now they haven't mentioned anything. They simply said, if simply open or closed organ pipe is mentioned, then don't take the end correction. So this is how you will realize whether to take end correction or not. Is that clear? Okay. Now let us go for some questions. An organ pipe 40 centimeter long is open at both ends. The speed of sound in air is 360. The frequency of second harmonic is. So these are the questions where you should not take into correction. Why? Nowhere they have mentioned the radius of the tube. Nowhere it's an experiment. And when I say experiment, they should use resonance column method. Resonance column method is an experiment. So nowhere they have used. As nowhere they have used, simply we have to go for the normal solving method without using end correction. So the frequency of the second harmonic, as it is a pipe which is open on both the sides, this is antinode and this is also what? Antinode. If these two are two successive antinodes, then it's fundamental frequency. But they are talking about what? Second harmonic. That means 2 should be multiplied to the fundamental frequency. Let us find out the fundamental frequency, because I am bad with memorizing stuff. From next time I'll directly use formula, but now I am again deriving this. Look, distance between two successive antinodes is going to be lambda by 2. That itself is equal to L. So from here lambda is going to be what? 2L. So the fundamental frequency we know it to be what? V by lambda. So which is going to be what? V by 2L. But the frequency they are talking about is second harmonic. That means 2 times the fundamental frequency. So if you can memorize the fundamental frequency of closed organ pipe and open organ pipe, it will save lot of time for you. Okay, it is 2 times. What is the V man? 360 divided by 2 times the capital L, 40 centimeters, which is 0.4 meters, right? It is 3600 divided by 4, which is going to be 900 hertz. So the frequency is going to be 900. Okay. Next, we have one more, which is JEE Mains 2023. In that, for a certain organ pipe, the first 3 resonance frequencies are in the ratio 1:3:5. Man, the first 3 frequencies are in what ratio? 1:3:5. That means odd numbers, right? Odd numbers means what? It's a closed organ pipe or not? Yes, it's a closed organ pipe. If the frequency of the 5th harmonic is 405 and the speed of sound in air is 324, length of the organ pipe is, as it is a closed organ pipe, the fundamental frequency is how much? Is V by 4L. And now they are only mentioning that the 5th harmonic is 405, right? So to the fundamental frequency, you multiply 5. So 5 times V by 4L is given as how much? 405. V is how much? 324 divided by 4L. So what will be the value of L? It is going to be 5 into 324 divided by 4 into 405. Right? 5 into 324 divided by 405 divided by 4, which will give you 1 meter. So the length over here is going to be 1 meter. Okay, next. A pipe open at both ends has a fundamental frequency F in air. F in air. The pipe is dipped vertically in water so that half of it is in water. The fundamental frequency of the air column. Obviously, in organ pipe, what is going to be the one which is going to be oscillating? The air column only. There will be a lot of air molecules. Those air molecules are the ones which are going to be moving. Okay, fine. Let us take the length to be L. Then the fundamental frequency of this one is going to be how much? V by 2L. Open organ pipe, na? So V by 2L. But now the very same pipe, what did they do? Half of it is filled or dipped into water. So what is the new length? you can treat it as a closed organ pipe. You can treat it as a closed organ pipe of length L dash, which is how much? L by 2. So what is the fundamental frequency of closed organ pipe? Fundamental frequency of closed organ pipe is V by 4 length of the closed organ pipe, which is V by 4 times L dash is what? L by 2, which will turn out to be how much? V by 2L. What is V by 2L? Already it is given as F. So the fundamental frequency of that closed organ pipe which got created is also going to be what? F only. Okay. One more 2019 question. 2019 question. A closed organ pipe has a fundamental frequency of 1.5 kilohertz. The number of overturns that can be distinctly heard by a person with this organ pipe will be, and they can hear up to 20,000. So look, the fundamental of the closed organ pipe is given as how much? 1500 hertz. What is the next one? What is the next one? The next one is going to be 3 times 1500. And the next one 5 times 1500. And the next one 7 times 1500. And the next one, you have to go like this, right? Right or wrong? So in order to find which one is going to be closer to 20,000, I'll do one small thing. 20,000 divided by 1500 I do, such that I will get to know what I have to multiply. Like which odd number is close to, that I'll get to know. So 20,000. So these two zeros can be cancelled out, right? So 200 by 15, 200 by 15 is going to be 13.333 and so on. So that means I can go up to 13 into 1500. What is 13 into 1500? 13 into 1500 is 19,500. That means up to 19,500 whatever have been created will be heard. If you go for the next one, which is 15 times 1500, which is going to be 22,500, can't be heard. So what are all the odd numbers? We can hear for 1, for 3, for 5, for 7, for 9, for 11, for 13, but not for 15, not for 17, right? So 1, 2, 3, 4, 5, 6, 7. How many can be heard? 7 of those sounds can be heard. Okay. Next. This is one important experiment, man. I tried my level best to portray it properly. This is the actual experiment you will have in the labs. Right? This is a diagram which is representing things properly, but this is the actual thingy. Look, we are going to have a metal tube. To that, a glass tube will be connected. What is the advantage of this glass tube? This glass tube and the level of the liquid in this metal tube, both will be what? Same. So as the glass tube is transparent, using the scale, whatever is there, I can measure to what level the water is there. If I know to what level the water is going to be there, then I'll get to know what is the length of the air column. What will be the length of the air column? I can easily measure, right? Then what is the use of this one? Man, this is going to be having lot of area of cross section when compared with this one. So overall what it does, I'll explain you. If you move this one up, then the water level in this also will go up. If you move this one down, then the water level in this also is going to go down. So basically, to change the water level in this, we are going to use this. So just blindly what you have to keep in mind, if you take this one up, water level in this also goes up. If you take this one down, water level also goes down. Now, what is this resonance column method? I will start with a situation where the water level in that left side pipe, water level in this left side pipe is going to be up to the brim, that is fullest. That means the initial water level, initial water level, the initial water level is to the full, right? Now, actually this experiment will be performed by two people. There will be your friend who is going to be holding on to this one, who is going to be holding on to this mug, right? You will unscrew this, you will loosen it, and you are going to make this mug slowly move down. If it is going to be slowly moving down, then the level of the liquid is also going to slowly go down. Okay. So as time passes by, what will happen? What will happen? The liquid level also will be changing. Okay. And meanwhile, when the liquid level is changing, do you know what I am going to do? I will have a tuning fork, man. I'll have a tuning fork. What I'll keep repeatedly doing is that I'll take the tuning fork, strike it, keep it above the air column. I have air column here. I have air column here. I have air molecules here. So these air molecules are going to be oscillating, or you can say they are going to be vibrating. Oscillating, they are going to be vibrating. Now look, if the frequency of oscillations of this air column and if the frequency of oscillation of the tuning fork, if both of them are going to match, then resonance is going to take place. That's when I hear loud sound, because the amplitude of oscillations of the particles will be maximum at resonance. And the intensity of the wave is directly proportional to amplitude square. More the amplitude, more is the intensity. So you hear a loud, weird sound if you have done the experiment. If you have done the experiment. So what is the kind of standing wave that gets created? For example, if you hear resonance in the sense loud sound, that means the frequency of this one and the frequency of the air column is what? Same. And it is just like what? It is just like a closed organ pipe with some end correction, and let us say this length to be what? L1. So you get a situation of L1 plus E to be equal to lambda by 4. This is your first equation. Again, my friend will keep on taking this water thingy down. As a result, water level will be keep on falling down, but I am using the same tuning fork, man. If I am using same tuning fork as we use same tuning fork, so the frequency is going to be V by lambda. Lambda is going to be V by F. See, speed of sound is constant. And the frequency we are talking about is the frequency of the tuning fork, which is kept constant. And the wavelength should be what? Constant. Now you tell me, when is the next resonance possible? You have 1/4 of the loop. The next possible is going to be what? One complete loop being accommodated. Let me draw the diagram, then you will understand what I mean. This much, right? This much. Let me draw it. Okay. When again you will have the air column oscillating with the same frequencies as that resonance is going to take place, is this. For this particular length, where it will accommodate one more same size loop. This is half loop. One complete loop. Because always antinode should be formed over here, and node should be formed over here, antinode should be formed over there. Always node here, antinode over here. And if the size of the loop is not changing, that's when the wavelength is not changing. That's when you get the same frequency of vibrations. Then if you hit the tuning fork and keep it above, Vibrations of this air column and the frequency of the tuning fork, both of them are same. Again you hear that loud weird sound, that is resonance, and you have an end correction. So now I can write L2 plus E to be what? 3 lambda by 4. Now from this and this, can we calculate the wavelength? Yes. So if you talk about this L2 minus L1, it is exactly accommodating one loop or not. This is one important observation. So equation 2 minus equation 1, if I do, I get L2 minus L1 to be equal to lambda by 2. So the lambda is going to be what? The lambda is going to be 2 times L2 minus L1. If I get to know the wavelength of oscillations, I know the frequency also. How I know the frequency of air column? When it resonates, frequency of air column and frequency of tuning fork will be what? Same. Okay. So now the frequency is going to be V by lambda. So V is going to be what? Frequency times lambda. What's the frequency? Frequency of tuning fork. What's the wavelength? It is 2 times L2 minus L1. From where we will get L2 minus L1? Experimentally, there is a scale which we can measure. So from here, they get the speed of sound experimentally. So resonance column method is used to find speed of sound in air. And one more thing, we can also calculate end correction. We can also calculate. Tarun S is asking, sir, is there any case with no end correction? No, in reality there will be end correction if we are talking about antinode. If we are talking about antinode, for sure there will be end correction, man. Okay, fine. Now, can we calculate end correction? Man, experimentally only they calculated and roughly they got it to be 0.6 times the radius. Right? Okay, now look, can we get that end correction? Yes, man. Put equation 1 in 2. How? Lambda by 4 is L1 plus E, right? So you put it in that. Put lambda by 4 as L1 plus E in equation 2, which is L2 plus E is 3 times lambda by 4, right? Which is L1 plus E. So now 2E is going to be L2 minus 3L1. Then the end correction is going to be what? L2 minus 3L1 divided by 2. Now look, sir, they are doing resonance column method, right? And they gave readings and they gave radius of tube also. Then should I take 0.6 times the radius as the end correction, or should I submit this as my answer? This you have to submit as your answer rather than 0.6 times the radius. Keep that in mind. Keep that in mind. Keep that in mind. Whenever they give experimental data, make sure to use this only for end correction rather than 0.6 times the radius. So now let us talk about questions on this resonance column method. The more questions we do, the more clarity we get. Come on. A student is performing the experiment of resonance column. Okay, fine. Diameter of the tube is 6 centimeter. The frequency of the tuning fork is 504. Speed of the sound at a given temperature is 336. 0 of the meter scale coincides with the top end of the resonance column tube. The reading of the water level in the column when the first resonance occurs. Okay. Look, man, first resonance occurs and they haven't given the L1, L2 values. No experimental results have been given, but they have given diameter. They have given diameter. So what is like end correction from diameter? 0.3 times the diameter. So 0.3 times 6 is going to be what? 1.8. So let us take this to be the tube. This to be the tube. Slowly you are taking the water level down. So your first resonance is definitely going to take place for a particular length, and obviously it is going to be your fundamental thingy. So this length I don't know, but I know this, which is 1.8 centimeters. Reason is what? This is equal to what? 0.3 times 6. 0.3 times diameter has to be used, right? Now look, they gave 336, they gave the frequency. So now lambda by 4 is going to be L1 plus 1.8 centimeter. So I'll get L1 also in terms of centimeter. Now lambda is 4 times L1 plus 1.8. Now frequency is going to be what? V by lambda. What is the frequency? 504. What is the V? They only gave it 336 divided by 4 times L1 plus 1.8. You have to get the L1, and that L1 is the reading the scale is going to show you. Where the scale is going to be? Let me go back. Look. This is the level, 0 will be marked, and this is the reading, and this is where you are going to get the reading of that first resonance thingy. You have to get the L1 value. Answer 14.8 it seems. I don't know, I didn't check the answer. But yes, 336 by 4 can be written as what? 84. Can be written as 84. From there you can do the calculations. Calculation is not difficult, you just do the calculation. Next, let us do this. Hello Vinodini Sarnath. Vinodini. Okay. In a resonance tube experiment, when tube is filled with water up to a height of 17 centimeters from the bottom, man, they haven't given the length of the air column. They said 17 centimeters from bottom. It resonates with a given tuning fork. When the water level is raised, the next resonance with the same tuning fork occurs at a height of 24.5. Now instead of increasing the air column, they are decreasing the air column, man. So you are going the reverse way. You are going the reverse way. Look. See, they said that so this one is 17 centimeters. 17 centimeters. So let us take a situation where you have this kind of situation. Now what did they do? They said that now the level of the liquid, when it is going to go till where the so diagrams are more important, man. They gave this to be how much? 24.5. So in that situation, what is the loop that is missing? The loop that is missing is this. So how much length you have moved up is nothing but the size of the loop. So how much is the size of the loop? 24.5 minus 17. So we can write 24.5 minus 17 as lambda by 2, because one loop is missing because of that much increment in the water level, right? So you get this to be how much? 7.5 lambda by 2. So the wavelength is 15 centimeters. Wavelength is 15 centimeters. Okay, fine. They are talking about what? Speed of sound in air to be 330. 330. Right? So the frequency is V by lambda. So the frequency 330 meters. Man, this is 15 centimeter. So you should write it as 15 into 10 to the power minus 2. So it is going to be 33,000 by 15, man. 33,000 by 15 will be how much? My brain is saturated, so I'll use calculator for calculations. It comes out to be 2200 hertz. So in the normal experiment, what we are going to do, in the normal experiment, we will slowly decrease the water level. And in this, what did they say? They are increasing the water level. That means they are going the reverse way of what the experiment is going to be. Reverse way of what the experiment is going to be. Super, super. People have answered it correct. Chahat Kumar, good man. Now, let us talk about one more question. A tuning fork of frequency 480 Hz is used in an experiment for measuring the speed of sound in air by resonance tube method. Resonance is observed to occur at two successive lengths. Man, two successive lengths means the length gap will accommodate one loop or not. Length gap or length difference will accommodate, look, the length difference will accommodate exactly one loop. That's the most important thing. Now look, can I claim L2 minus L1 to be blindly lambda by 2? So what is lambda? 2 times L2 minus L1, which is 40 centimeters. So the lambda is going to be how much? 80 centimeters. I think they are talking about what? The speed of sound, right? They gave frequency. Now look, we know that the frequency is going to be V by lambda. So V is going to be what? Frequency into lambda. What is the frequency? 480. What is the wavelength? 0.8 meters. You have to put it in meters. So it is 48 into 8. That means end should have 4. Why? 48 into 8, the last two digits, if you multiply, you'll get 64. So the end should have 4. Only one option is having end as 4. So I'll directly mark option B rather than doing any calculations. Very good, Chahat Kumar. Very good, Chahat. Tarun, it's not 332, man. We're not getting 332. You just check the calculations once. Okay, we are to the last part. We are almost done. Now I'm going to do some experiments for you. Okay. Might be it is going to be quite disturbing. You can reduce the intensity. Like loudness of speakers, or if you are listening in earphones, I'm warning you. The sound is going to be a bit disturbing, man. Right? I'm doing an experiment. You people also can do that. So you can open and you can type in online tone generator. And please open it in 2 tabs. Online tone generator. Right? I'm pressing the second one. Online tone generator, the second one I'm pressing it. Right? So by default, you can see that there are some options. 440, right? 440, play, stop, save. Right? These are the options we have. Now, when I play 440 alone, shit, can you people hear me? Or yeah, I think it is getting cancelled out, man. Can you hear any sound? Can you hear weird loud sound? I think the mic is cancelling it off. Just confirm me once. Just a second, please confirm me. Can you hear some weird loud sound? Like continuous kind of. Sumesh, I have already done sound waves, man. Okay. Flat, loud sound. Okay. I'll cancel out the noise cancellation. Okay. So, in one tab, I have kept 440. Now, I'll use one more tab. Same thing. Online tone generator only I am typing. I have typed. and when I go, there will be default 440. I will change it to 441. So in one tab I have 440, in the other tab I have 441. Now look, 441, a flat sound. 441 is a flat sound. Now I'll keep this as it is and I will play 440 which I have kept ready in the other tab. Can you notice something? A flat sound has become loud, slowly decreasing intensity, then no sound, then loud, no, like that. Can you hear that? Now I will make the frequency from 441 to 442. The frequency of that kind of disturbance or that kind of sound has doubled. What has happened, I'll tell you. You people can do this at your home also, right? Yes, it's not a continuous sound. It's not a continuous sound. So what happened, I'll tell you. What happened, I'll tell you. Look, when 440 and 441 were mixed together, I was having one loud sound and one no sound in 1 second. When I played 442 and 440, I was having two loud sounds and two low sounds in 1 second. See, one loud sound and one low sound is going to be called as a beat. Why it is called as a beat? For example, you think in this way, you have drums. When you beat it, that's when you get sound. Then again you'll take your hand up, again you'll beat it. Then again you'll get sound. So what is a beat? That sound plus no sound is called as a beat. So you can say in this way, one maxima along with one minima is going to be called as a beat. And how many beats are going to be heard by you per second means it is simply the difference of frequencies. When I played 441 and when I played 440, when I played 441 and when I played 440, I got one loud sound and one low sound. When I played 442 and 440, for every second I had one loud, low, again low. If you want, it's very easy on your mobile phones. You can open online tone generator, you open multiple tabs and you play them. So why is that happening? Why those beats are getting generated? Let's talk about that. And one more thing, when I played it, when I played 441 and 440, I heard one loud sound and one low sound. And in fact, you people sitting at different parts of the country also heard one loud sound, one low sound. So what I am trying to tell you is that whatever I hear, you people also will hear the same thing, indicating it doesn't depend on the position, whether it is Madhan or whether it is Tarun or whether it is going to be Sumesh or someone else. It doesn't matter. Okay. So the number of beats heard by me and by you people is same. So when that is happening, when I'm mixing 440 and 441, what is 440 and 441? Those are two waves of close by frequencies. Two waves of close by frequency. Okay, so let us take two waves. Okay, just a second. Y1 is some A sine omega 1t minus k1x. Y2 is some A sine omega 2t minus k2x. So what will be the resultant you are going to come across when both the waves are going to be traveling in the same medium? So the resultant is going to be y1 plus y2, right? So the resultant, I should write it as what? I should actually write it as A sine omega 1t minus k1x plus a2, oh, not a2, a sine omega 2t minus k2x. For simplicity, I will talk about x is equal to 0, man. Why? Whatever is going to be heard by the person at x is equal to 0, same is heard by me, same is heard by you. When you play the audio, whatever I have whatever I have said to you or whatever I have given to you, when you play the audio, every one of us heard the same thing. So for easier calculation, if I can get rid of this x terms, it's easy to calculate. So let's see what is happening at x is equal to 0. Let's take x to be 0 for easier calculation. Then what will happen? The resultant is going to be a sine omega 1t, a sine omega 2t. So what are you going to get? Are you going to get sine c plus sine d or not? Yes. What is sine c plus sine d? 2 sine c plus d by 2, what? Cos c minus d by 2. So it is going to be 2a sine c plus d by 2, omega 1 plus omega 2 by 2, and cos omega 1 minus omega 2 by 2, this one. So I will write this one as 2a cos omega 1 minus omega 2 by 2 into t. This whole thing I'll keep it as 1, and sine omega 1 plus omega 2 by 2 into t. Man, you have two trigonometric functions. One is cos, other is sine. Which one will be changing faster? This is going to change faster because it has more omega. Whichever has more omega will change faster. Whichever has less omega will change slower. Sir, I didn't understand, sir. Okay. If you don't understand, I'll take an example. So the example is going to be omega 1, I will take it as 202 pi. Omega 2, I will take it as 200 pi. Okay. So for example, for you to understand, that's why I'm doing it. Now that resultant is there, 2a cos omega 1 minus omega 2. That means 202 pi minus 200, which will be 2 pi. 2 pi by 2 will be pi. So cos pi t. And what about the other one? Omega 1 plus omega 2 by 2. That means 202 plus 200. 402 by 2. That means it is going to be 201 pi into t. Man, in t is equal to 2 seconds, this cos will become 2 pi. And what about this sine? This sine will become 201 into 2 pi. Agreed? That means in 2 seconds, cos did one cycle. In 2 seconds, cos has done only one cycle. One cycle means it's nothing but angle going from 0 degrees to 2 pi radians. 0 radians to 2 pi radians. Now, if you talk about the very same thing, sine has done how many? 201 cycles or not? It is 201 into 2 pi. So that's what I was telling you. This is something which is changing very fast. This is something which is changing very slow. So we have something which is changing very slow. We have something which is changing very fast. So this is going to be giving us amplitude, man. This will give you amplitude. Sir, again I didn't understand. Give me better explanation. Okay, I will give you that. I am saying you that I clearly proved that this changes very slow. Let's say, let's say, let's say at at t is equal to half second. T is equal to half second. This is it, right? At t is equal to half second, what will be the uh, this? What will be this? Resultant is going to be 2a cos pi by 2, and this is going to be sine 201 pi by 2. And what is this one? It is 0. So if t is slightly greater than half also, slightly greater than half, then more or less cos value will be approximately 0 only. Cos value will be approximately 0 only. Why? Cos is changing very slow. So if you go slightly beyond half second, cos value will be more or less 0, but this one changes very fast. So you can treat the slow moving part to be your amplitude, and this contributes for more oscillations. So as a result, when I am going to be plotting, the displacement versus time thingy, the amplitude of oscillation will be changing slow. Right? This yellow one is represented with 2a cos omega 1 minus omega 2 by t, omega 1 minus omega 2 by 2 into t. That's changing very fast. And what about this sine? Sine is doing more and more oscillations, man. So the amplitude of oscillations is decided by this blue one. And you can see that amplitude is changing gradually. So for long amount of time, the amplitude of oscillation was smaller. So if the amplitude of oscillation is small for longer duration, the intensity of the wave will be small. That's why we heard low sound. And for long duration, the amplitude of oscillation was big. So the intensity is going to be higher. That's why our ear was able to perceive that. So for our ears to perceive, for our brain to process, they should exist for certain amount of time. Because of combining two frequencies which are close by, I got enough time to perceive this low sound and big sound because that amplitude stayed there. Man, if the gap is big, then omega 1 minus omega 2 will also be big. Then this will also be changing very fast. If it is also going to be changing very fast, our brain doesn't have time to process those fast changing sounds. Then our brain will process the average sound. If you want, now you do one thing. You play 400 in one tab and you play 800 in the other tab, then you will get a flat sound. It's a weird one, but it will be a flat sound. Okay. Now, Okay. So beats are heard only when you club two waves of close by frequencies. Why? You get enough time. As this is going to be changing very slowly, you will have enough time where the amplitudes are very small, where the amplitudes are very big, for your brain to process that loud sound and no sound. Okay, so this is the factor. This is the one who is responsible for those beats, right? Now, I want to find out when that amplitude is maximum. So we have 2a cos omega 1 minus omega 2 by 2 into t. Let me just find out when it is going to be plus r minus 2a. So, because that's when it's maximum, right? So it should be plus r minus 1. That means omega 1 minus omega 2 by 2 into t can be 0, can be pi, can be 2 pi, and so on. Right? So what will be the t value then? 0, 2 pi by omega 1 minus omega 2, and then 4 pi by omega 1 minus omega 2, and so on. So these are the times at which I am going to be listening to maximum sound. So between every maximum sound, there will be one minimum sound also. Where is it? You can see here amplitude is maximum, here amplitude is minimum. Again, for the amplitude to become maximum, you have to go through a minimum or not. That's what one loud sound plus one low sound is going to be called as a beat. Okay. Now look. So the time gap between two successive loud sounds, can I call it as one beat? Time gap between two loud sounds. Why? Loud, no, low, and loud. So one loud plus low is going to be what? A beat. So the time period for two loud sounds, time gap between two loud sounds is how much? 2 pi by omega 1 minus omega 2. Okay, this is the time period between two maximas. If you if you find for two minimas also, it will come out to be same. Two minimas also, all you have to do is put 0, then also you'll get the same time gap between two minimas. Okay man, now look, I want frequency. That means in 1 second, how many times I hear those loud sounds is going to be the number of beats. So the frequency is going to be 1 by time period. So the frequency of the beats. Why? The number of times you hear that loud sound is the beat. So more the number of loud sounds, more the number of beats. 1 by t, right? Which will be what? Omega 1 minus omega 2 divided by 2 pi. So I can write it as omega 1 by 2 pi minus omega 2 by 2 pi, which is going to be what? F1 minus F2 is going to be the number of beats. And always keep in mind, F1 should be taken as the bigger one, F2 should be taken as the smaller one. You have to choose F1 as the bigger one, F2 as the smaller one. That's it. Deepu fighting with JEE. Sir. No, I haven't done beats. Deepu, I haven't done beats. Beats, I am doing it for the first time on the Vedantu platform. Beats, I am doing it for the first time on the Vedantu platform. Okay. So, how many beats are going to be heard by you? It is going to be difference of the frequencies. So, if it is 402 and 400, 402 minus 400 is 2 beats per second. That means you will hear two loud sounds. Okay. Next. What is this waxing and filing of tuning forks? See, using this, we can slightly change the frequency of the tuning fork. For example, the tuning fork, whatever is going to be there, if to the prongs of the tuning fork, if I put some wax, then as the mass has increased, by doing the waxing, as the mass has increased on the prongs, the the frequency slightly decreases. The frequency will slightly decrease. Then what is filing, sir? What is filing? In filing, they take a sandpaper. I hope you people know the sandpaper. So they take the sandpaper and they're going to rub the prongs. Using that sandpaper, they'll rub the prongs. As a result, the prongs will lose some mass. When the prongs are going to become thinner, and when they lose, frequency of tuning fork slightly increases. So if you are in need of a situation that you have 256 tuning fork Hertz frequency tuning fork, 512 Hertz frequency tuning fork, but you want 520, then you can do filing. Slightly you do filing, then you will get 520. You have 512 one, but while doing the experiment, you need 510. Then what you do is you put some wax onto the prongs, then the frequency will go down. Okay, fine. Do these questions. We are almost at the end. And at the end, I will give you beats for more than 2 sources. In all the books, you are going to have beats for 2 sources. And the number of beats are going to be F1 minus F2. The number of beats are going to be F1 minus F2. But I'll give you more. I'll give you better. That is, for more sources, how many beats are going to get produced. I have verified it with, you have this app called as Desmos, right, in math. Like you can input trigonometric functions into it and it will give you the graph. So using Desmos, I found it. A tuning fork of frequency 512 Hz is vibrated with a sonometer wire and 6 beats per second are heard. Man, whenever they say 512, 6 beats, there are 2 possibilities, man. When they say 6 beats, it can be 506, it can be 518, right? So we don't know. In both the situations, you will get 6 beats only. See, tuning fork is 512. Sonometer frequency can be 506 or 518. Look, the beat frequency reduces if the tension in the string is slightly increased, the original frequency of vibration of the string. See, tuning fork is 512. We need to find the vibrations of the string. So the vibrations can be 506. The vibrations of the string can be 518. If it is 518 also, you will get 6 beats. If it is 506 also, you'll get 6 beats. Now they will give additional data. What is that additional data? They have increased the tension, right? Just tell me one thing. If they increase the tension, I think wave speed will increase. If wave speed is going to be increasing, what will happen to the frequency? It will also increase or not? So if 506 increases, then it goes closer to the 512. So the number of beats decrease. Why? Where if it is actually 506, if you increase the tension, frequency is going to be V by lambda. If V increases, the frequency has to increase. As a result, from 506, for example, if it becomes 510, then 510 and 512, number of beats will become 2. If it is this case, then by increasing the tension, frequency will further increase. Then it will become, let's say, 520. 520 minus 512 will be what? 8 beats. So if this is the case, then the number of beats should increase. What did they mention in the question? The frequency reduces if the tension in the string is slightly increased. So if the beat frequency has to decrease, then for sure it should be 506. So I will go with 506. If it is a single correct one, I'll go with 506. Okay, fine. Next, take this. A tuning fork having n is equal to 300 Hz produces 5 beats per second. 5 beats per second. With another tuning fork, they haven't given what is the frequency of that tuning fork. Only one tuning fork frequency they gave, 300. How many beats, man? 5 beats it seems. So to produce 5 beats, either this can be 295 or it can be 305. So the other frequency, the other tuning fork frequency can be 295 or can be 305. Okay, I'll answer that, Deepu. First do this. If impurity is added on the arm of the unknown tuning fork, that means this is the unknown one, right? So what they are doing to it, they are doing waxing. If waxing is done, beats should decrease. If the beats are going to decrease, for example, from 295, if it becomes 290, then 290 and 300, the number of beats will become 10, right? So the beat frequency, if you do that, the beat frequency increases if the tuning fork, whatever the unknown one we are talking about, is 295. If the tuning fork is going to be having 305, if it slightly decreases, for example, if it becomes 302 and 300, so the number of beats will decrease because 302 and 300 will have 2 beats. So the beat frequency initially will definitely decrease. So now you look at the question. The number of beats decreases. So the number of beats will decrease if the frequency we are talking about is 305. So the unknown tuning fork's frequency is 305. If it is a single correct answer, definitely you have to choose this only. Okay. Next, do this. 2022 JEE mains question, do this. And then coming to you, Deepu. Intensity depends on frequency. Yes, I have done it in the previous class. Intensity of a wave depends on the frequency. How? Half rho a square omega square into V, where omega is angular frequency. You can put it in frequency. You can put it in the frequency form. The velocity of sound in a gas in which two wavelengths 4.08 and 4.16 produce 40 beats in 12 seconds will be. They gave wavelengths, right? They said 40 beats in 12 seconds. So how many beats per second? That you have to find. Now, if I am going to talk about the frequency is going to be V by lambda, right? Frequency is going to be V by lambda, right? So, F1 is going to be V by lambda 1, which is 4.08. F2 is going to be V by lambda 2, which is 4.16. So, the beat frequency is going to be what? F1 minus F2. How many beats per second? 40 by 12. Beats per second are going to be 40 by 12. So I can say 40 by 12 is going to be V by 4.08 minus V by 4.16. So you have to calculate what? The V value. So the V value, when we are going to talk about 10 by 3, so the 10 by 3, the V is going to be 4.16 minus 4.08 divided by 4.08 into 4.16. So you get the value of V. Do the math, get the value of V. Okay. So these are the questions which have been asked on the beats 2021. A tuning fork A of unknown frequency produces 5 beats with a fork of known frequency 340. That means that unknown frequency can be what? It can be 335 or it can be 345. A is filed and A is the unknown one. So you draw it like this. Look man, 340 is a fixed one, right? So the possibilities are 335 and 345 to produce 5 beats, right? Now what are they doing? The unknown one, they are filing. If they are going to file, what will happen to the frequency? Filing increases the frequency. So now look, if 335 increases, let's say it is becoming 338, in 338 and 340, then what will happen? The beats will decrease. Beats will decrease in this case. Now from 345, if it is going to increase, if it is 348, 348 minus 340 will be what? 8. So the number of beats here will be increasing. So if the unknown one is having a frequency of 345, beats should increase. If the unknown tuning fork frequency is 335, then the beats should decrease. What did they mention in the question? The beats are decreasing. If the beats are decreasing, for sure I should mark it to be what? 335. So these are the type of questions they are going to be asking. These are the type of questions they are going to be asking. Satvik Sarangi, Namaskar. Namaskar. Now look, this is one extra thing I am giving to you. So being my students, I'm just giving you one extra advantage. Is it mandatory that always there should be 2 sources? Nah. Even in mains also sometimes they have given 3 sources. For example, if you have F minus 1, F and F plus 1, then they are going to ask you to find number of beats. With the trick I am going to give to you, you will get the answer to all these questions easily. Trick is going to be, the trick which I am going to give you is something which I have worked a lot and Desmos has helped me a lot. Desmos, you just mark it, just note it down. What is the trick? Always the highest frequency minus the lowest frequency is going to be the number of beats that are going to be produced. But there is going to be some variation in the quality of those beats. What is that variation? That also I'll talk about. Now for this question, how many? What is the highest? Highest is F plus 1 minus F minus 1 is going to be the number of beats that are going to get produced. So what is the answer? The number of beats is going to be 2. But do you know what will happen when more than 2 are going to be? For this case only, if I am going to talk about this particular case only, when I am going to be plotting the variations, like how the amplitude is going to be changing, let me show you how the amplitude is going to be changing. How I got this? With the help of Desmos. I'm telling you, with the help of Desmos, I got this. You can put in a lot of trigonometric things into the Desmos thing, and the Desmos will give you the graph. So the oscillations in the case of more than one source is going to be looking like this. So what will happen to you is that, see, this is one loud sound. Here you get some loud sound. Here you are going to get some very low sound. And again you are going to get a loud sound, but the loudness of this sound is less than this one. So you get maximas, but the maxima we have here, it has a loud sound, and the next loud you are going to get is less in intensity when compared with the first one. So we have two beats, one loud here and one more loud, but this loud is having less intensity than the intensity of this loud sound. This is what happens when multiple sources are going to be put together. Okay. So online tone generator is there for you. From that online tone generator, you put 440, one more tab 441, one more tab 442. You do that. When you do, you will clearly listen to one loud beat and then low sound and then slightly higher loud beat and then low sound, again high beat, low sound, slightly higher beat, low sound, again big sound beat, low sound, slightly higher sound beat, again big beat, like that. So the beats that are going to get produced will not have same intensity if the source is going to be, if the sources are going to be more than 2. If you ever want to feel it, as I said, if you want to feel what I have given to you, blindly open the online tone generator, 440, 441, 442. Now I'll give you one last thing. In fact, for example, there are 4 sources. One is 400 Hz, the other is 402 Hz, and the other is 403 Hz, and the last one is 405 Hz. So if they ask you the number of beats that are going to get produced in this case, man, shortcut I gave you. Those who want to verify, Desmos, there is an app called as Desmos, verify it. You don't need to sit and do the whole calculation. What is that shortcut which I have given? The highest minus the lowest is what you have to do to get the number of beats. So highest is 405, lowest is 400. So you get how many beats? 5 beats. But if you ask me, will all these 5 beats be same? No. Some beats will have loud sound, some beats will have less loud sound. So all the beats produced are not going to be identical. That is one thing which you have to keep in mind. Ayush Aher, Namaskara sir, Channagidira, Channagidri, Channagidira. Ayush, Channagidira. आप भी अच्छा, आप भी अच्छा पढ़ाते हैं. Okay. So with this we are done, man. We are done with waves. You people can start solving. There is no Doppler effect. Doppler effect has been removed. Even 2025 JEE mains also have verified. Doppler effect is removed. Okay. Bye then. All the best. Keep working hard. With this, every part of waves has been covered. Good night. Keep working hard.